Hello there, and welcome to The Ancient Historian, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we begin a journey not forward but backward, into the deep history of our planet. Our focus is a time long before people, long before recorded memory, long before anything we might comfortably call civilization. We will wander across spans of years so vast they stretch not in centuries, not in millennia, but in millions, and even tens of millions. Imagine, if you will, peeling back the layers of time itself, like pages in a book, until we are standing on the shore of forgotten ages, looking out at a world that may have known wonders now erased. The question before us is simple, yet unsettling. What if humanity is not the first? What if another civilization once walked this earth, flourished and fell, leaving behind little more than whispers buried in stone and soil? When we think of civilization, we think of the familiar measures. Cities with streets, monuments, art, writing, and tools. By this definition, humanity's story of civilization spans only a sliver of time. The first true cities emerged around 10,000 years ago, in Mesopotamia, the Fertile Crescent. That is a mere blink when compared to the vast age of the Earth itself, which has endured for 4.5 billion years. Even if we narrow the stage to life complex enough to dream, build, and perhaps imagine itself, say, the last 500 million years, we still face an ocean of time so wide that human history becomes like a grain of sand lost in its depths. Pause for a moment with that thought. In those hundreds of millions of years, how many ages rose and fell? How many forests grew into stone? How many seas dried to deserts? How many mountains lifted skyward and crumbled into dust? If entire continents can vanish beneath the waves, could not the traces of a civilization be swallowed too? Geologists remind us that Earth is restless. It renews itself, erases itself, reshapes its surface. The crust shifts, mountains rise, glaciers grind, rivers carve valleys, volcanoes bury, oceans consume. A human city built on the shore today, if abandoned, might crumble in just a few centuries. Give it 10,000 years, and nature would reclaim it so completely that only the faintest scars might remain. Now imagine 10 million years. 100 million years, 200 million years. In such gulfs of time, the works of hands, whether human or not, could vanish almost without a trace. Yet, there are whispers. The idea that perhaps we are not the first has been entertained not only by storytellers, but also by scientists. In 2018, astrophysicist Dr. Gavin Schmidt and planetary scientist Dr. Adam Frank posed what they called the Silurian hypothesis, named after the Silurians, a fictional ancient race in British science fiction. Their question was this: if an industrial civilization had arisen millions of years ago, would we be able to detect it today? Their conclusion was sobering. Evidence, they argued, would be exceedingly hard to find. Fossilization is rare and erosion is relentless. Beyond a few chemical signatures in the geological record, there might be almost nothing left. Consider how thinly the fossil record itself represents the living world. Of all the countless animals that once lived, only a fraction were ever fossilized, and only a fraction of those have ever been discovered. For an ancient civilization, the odds of survival are even smaller. Steel corrodes, glass shatters, concrete crumbles, plastics degrade. Even if skyscrapers stood tall, in 10 million years they could be dust, and the Earth would keep its secrets well. But still, our imagination lingers. Could there have been cities before cities, stories before stories, civilizations before ours? If so, what kind of beings built them? Did they look like us? Did they walk on two legs? Did they dream beneath stars? Did they know love and war and wonder? Or were they something stranger? Something we might not even recognize as civilization? The span of time is immense enough to allow such speculation. Modern humans, Homo sapiens, have existed for about 300,000 years. Yet dinosaurs, for example, reigned for over 165 million years. If intelligent life capable of building had emerged in even a fraction of that span, it would have had more than enough time to rise, thrive, and vanish. And remember, we ourselves have gone from crude stone, tools to computers and spacecraft in less than 300,000 years. What might another species have achieved in 5 million? In 50? In 100? Let us drift deeper. Imagine walking through a dense primeval forest, not of the human past, but of the Earth's deeper memory trees rising like cathedrals. Air fit with warmth and the scent of green life. Somewhere, far beyond what the eye can see, a civilization might stir. They build not in concrete or steel, but in materials now lost to time, materials that might leave no trace for us to find. Their monuments might have been torn down by shifting tectonic plates, their libraries consumed by fire, their machines dissolved to nothing beneath seas that have long since shifted away. Perhaps what we call natural formations, odd stones, puzzling alignments, unexplained geologic anomalies, could be more than coincidence. Perhaps not, but the possibility is enough to haunt us. A block of stone shaped by erosion can look like art. A fossilized ripple in rock can look like script. Our mind hungers for patterns, yet sometimes it wonders if those patterns are more than imagination. It is not only ancient geology that raises questions. Archaeology too offers puzzles. Around the world, there are structures whose age and origin remain uncertain. The pyramids of Egypt, built some 4,500 years ago, are young compared to the Earth, yet their endurance makes them seem eternal. The stones of Göbekli Tepe, in modern Turkey, are at least 11,000 years old, built long before the first cities we thought we knew. And if people could do that so early, what else might have been done before, in ages erased? The mystery deepens when we consider myths. Nearly every culture tells stories of lost worlds. Atlantis sinking beneath the sea, Lemuria fading into the waves, forgotten golden ages swept away by fire or flood. Myths are not evidence, but they echo. They whisper of something remembered, or perhaps imagined, or perhaps both. Could these tales be fractured memories of something real? Or are they only the dreams of human longing, cast backward into the darkness of time? Close your eyes and imagine the earth not as a static rock beneath your feet, but as a vast library. Every mountain, every cliff, every canyon a bookshelf filled with pages millions of years thick. Each layer of stone and sediment is a timekeeper, a witness to ages that came and went long before our kind ever learned to walk upright. If we are to even wonder whether civilizations rose and fell before us, this is where we must begin, with the patient testimony of the Earth itself. Geologists tell us that our planet is about 4.54 billion years old, a span of time so vast that even the rise and fall of empires, kingdoms, and nations we know today are but faint pencil marks at the very end of the story. Human civilization in its recognizable form, cities, agriculture, writing, has only been around for roughly 6,000 to 10,000 years. Even if we extend the definition generously, counting the earliest signs of symbolic art and organized behavior, we reach back maybe 50,000 years. But against billions, these numbers are a whisper against the roar of time. Consider this. The dinosaurs ruled the Earth for about 165 million years. For context, humanity's entire existence as a species, Homo sapiens, is thought to stretch back only about 300,000 years. That means the dinosaurs flourished over a period more than 500 times longer than our species has even existed. If civilizations like ours building, inventing, expanding could appear and vanish within a few millennia, is it truly unthinkable that in the long silences of prehistory, something might have risen and fallen without leaving much behind? The earth, after all, erases. Wind wears mountains down to sand. Oceans swallow coastlines. Volcanoes bury landscapes. Ice grinds stone to powder. And beneath it all, the crust of the earth itself moves, recycling old surfaces back into the mantle over spans of millions of years. What chance would fragile human-scale artifacts have of surviving hundreds of millions of years, let alone billions? A skyscraper left untended would crumble in a few thousand years. A metal bridge might corrode away in a few centuries. Even the pyramids, though massive, would eventually erode to dust if given tens of thousands of years. This is where the Silurian hypothesis enters a thought experiment put forward by two scientists, Gavin Schmidt and Adam Frank, in 2018. They asked a daring question. If an industrial civilization had existed on Earth millions of years ago, how would we know? Would we even be able to detect its traces in the geological record? Or would erosion, subduction, and the sheer churn of Earth's processes wipe away nearly all evidence? Their answer was unsettling. We might not know at all. Instead of searching for monuments or tools, the key would be chemical. Civilization leaves behind fingerprints, not in stone, but in the soil, in the air, and in the chemistry of sediments. Consider our own modern age. We are pumping billions of tons of carbon dioxide into the atmosphere, altering the climate. We are scattering plastics, synthetic chemicals, and radioactive isotopes across the globe. In millions of years, if geologists of some future species were to study our time, they wouldn't find skyscrapers or smartphones. They'd find a thin layer in the rocks marked by unusual carbon levels, strange metals, and chemical compounds that don't occur naturally. Now imagine if such a layer already exists, buried deep in the Earth's strata, waiting for curious minds to uncover it. Some geologists note curious spikes in carbon isotopes in certain ancient layers, changes in climate that happened abruptly, not unlike what is happening today. Could these be evidence of earlier civilizations? Or are they simply natural fluctuations caused by volcanic outbursts, asteroid impacts, or shifting oceans? Science usually favors the natural explanations, but the possibility lingers. And so we turn to the rocks themselves. The Permian-Triassic extinction event, about 252 million years ago, saw the death of more than 90% of Earth's species. The causes are debated: massive volcanic eruptions, runaway climate change, perhaps even methane release from the oceans. But one haunting thought is whether such devastation could also reflect the consequences of something artificial, an industrial pulse lost to time. It is speculation, yes, but speculation rooted in the undeniable gaps of the record. When we look at the Cretaceous-Paleogene boundary, about 66 million years ago, we see a line in the rocks rich in iridium, an element rare on Earth but common in asteroids. This tells us of the great impact that ended the reign of the dinosaurs. But what if there were other lines, not caused by rocks from space, but by activities once carried out by intelligent hands? To ask such questions is not to claim certainty, but to stretch our imagination in ways that keep history alive, not as a closed book, but as an open question. The Earth remembers, but it remembers selectively. Think of the Grand Canyon, with its colorful layers of sandstone, shale, and limestone, each band a window into hundreds of millions of years. Yet between those bands lie gaps, missing chapters, where erosion stripped away the record before the next layer was laid down. Geologists call these breaks unconformities. And in those missing spans, sometimes tens of millions of years long, who is to say what stories may have unfolded? Think about knowledge that survived in indirect forms. Stories, myths, or symbolic representations passed down through time could encode fragments of information from vanished civilizations. Patterns in rock art, repeated symbols, or recurring themes in myths across continents might reflect shared origins or contact between societies. In South America, certain spiral motifs appear in both ancient petroglyphs and oral traditions about cycles of destruction and renewal. In parts of Africa, geometric carvings etched into rock walls bear striking resemblance to those found in distant parts of Asia, hinting at connections that conventional timelines cannot easily explain. Even in Australia, Aboriginal songlines trace routes across the land that align with ancient geological pathways, suggesting that memory was mapped directly into the environment itself. These fragments of inherited memory, spread across cultures and landscapes, show up in ways that are sometimes subtle, sometimes startling, as though scattered pieces of a larger pattern waiting to be recognized. The Earth is an old book, but not one written in paper and ink. Its chapters are pressed into stone, carved into canyon walls, and scattered in layers of soil beneath our feet. Archaeologists, geologists, and curious wanderers alike have learned to read these layers, like librarians of deep time, decoding an archive that stretches back billions of years. As we leaf through this monumental library, there are passages that hint at processes, patterns and anomalies, fragments that survive fire, flood, and tectonic upheaval. If a civilization older than ours once walked this earth, some of their marks, subtle or disguised by time, might still rest in stone, waiting for discovery. Imagine an archaeologist standing in the middle of the Sahara Desert. Beneath endless dunes of shifting sand lie traces of rivers that once flowed like green lifelines. Fossilized fish, crocodiles, even petrified forests rest in silence under the burning sun. These are reminders that the land we now see as barren once teemed with abundance. Bones, shells, pollen, and carbon traces tell part of the story. But cities, roads, temples, machines, or art, if they existed, would have faced relentless erosion. Skyscrapers pulverized into quartz sand, highways dissolved into clay, and metalwork oxidized into indistinguishable sediment. The Sahara, like other deserts and plains, might hold secrets only detectable through subtle chemical and geological clues. Deep in the strata, oddities appear that defy easy explanation. Mysterious spheres of metal found in 2.8 billion-year-old rock in South Africa, bare grooves etched as though deliberately carved. Are they natural formations, sculpted by geological forces? Or are they remnants of something far older than known human civilization? Each interpretation sparks debate, evidence quietly stacked in layers of sediment and rock, awaiting scrutiny from those willing to peer beneath the surface. Then there are megaliths scattered across the world. Göbekli Tepe in Turkey rises from 11,000 years ago, predating agriculture and pottery. Its massive pillars carved with animals and symbols. These structures suggest sophisticated thought, shared myths, and cultural memory. If we dig even deeper into the soil beneath, or in other regions, might we encounter traces of monuments older still? Stone could have turned to sand, metal melted into the earth, and wood rotted into nothing. Yet hints may persist in mineral alignments, unusual soil composition, or isotopic anomalies. Geology writes and rewrites the earth continuously. Continents drift, oceans open and close, mountains rise and erode. Plate tectonics recycles the crust, obliterating most surface evidence older than a few 100 million years. In this relentless cycle, cities, tools, and artifacts vanish. Subtle markers may remain in the chemical record, metals concentrated unnaturally, isotopes that tell of atmospheric shifts, traces of soot in sediments that hint at combustion. Detecting these requires a combination of science, imagination, and an eye for anomaly. Consider layers of coal and sediment. Occasionally, objects appear embedded. Iron pots, carved figurines, even a supposed hammer, trapped in stone millions of years old. Most explanations point to error, misinterpretation, or hoaxes. Yet the presence of these objects in ancient layers raises questions. Could some hold clues to lost knowledge, remnants of a civilization that predated humans? Each object, each anomaly, sparks further investigation into how such materials might have arrived in their context, prompting scientists to explore patterns in chemistry, geology, and mineral deposits. Fossilized footprints introduce another avenue of intrigue. Tracks of dinosaurs, mammoths, and other ancient animals dominate the record, yet scattered reports describe human-like prints in strata far older than our species. In Texas, Turkey, and Russia, explorers have found impressions with arches and toes, resembling humanoid forms. Mainstream science attributes them to natural processes, erosion, or coincidences in rock formation. Still, the patterns prompt researchers to examine the sedimentary structures, distribution, and orientation, probing whether unknown agents could have interacted with these landscapes. Myths, legends, and stories offer yet another layer of possibility. Tales of great floods, vanished lands, gods among mortals, or golden ages destroyed by hubris appear across cultures. Atlantis, Mu, Lemuria, these names float like fog between history and imagination. While most scholars interpret them as allegory or cultural memory of natural events, some patterns suggest that myths could encode fragments of ancient experiences. The recurring motifs of sunken cities, lost knowledge, and catastrophic upheaval invite inquiry into whether there are connections between distant stories and evidence hidden in Earth's crust. In examining chemical and isotopic records, anomalies appear that defy straightforward explanation. Concentrations of rare metals, sudden shifts in carbon levels, and unusual isotopic ratios emerge in different geological periods. Forest fires might have left spikes of soot detectable in sediment. Mining could leave elevated copper or other alloys, and traces of radioactivity could hint at activities we cannot yet understand. These anomalies act as puzzles, scattered across time and space, prompting researchers to map patterns, explore correlations, and seek connections between disparate data points. Even the landscape itself contains clues. Altered riverbeds, strangely arranged rock formations, and sedimentary layers with unexpected compositions suggest purposeful modification. In deserts, mountains, and coastlines, the land bears subtle fingerprints of movement, excavation, and deposition. Fossilized forests and petrified lakes intermingle with mineral anomalies, while ancient waterways hint at the engineering of terrain. Evidence is fragmented, hidden, and often ambiguous, yet it forms a lattice of questions, inviting curiosity about civilizations whose presence may have been erased from the visible record. As we wander deeper into the mists of time, let us turn our gaze to the stories humanity has always told itself, stories that may contain fragments of something far older than the civilizations we know. Myths are windows into the minds of ancient peoples, but they may also be echoes of events and beings that predate even the earliest recorded history. Atlantis, Lemuria, Mu, names that evoke mystery, wonder, and civilizations whose traces may be hidden beneath layers of earth and water. Atlantis, perhaps the most famous of lost civilizations, was first described by Plato around 360 BCE. According to him, it was a mighty empire, rich in metals, advanced in technology, and politically sophisticated, that fell in a single day and night of catastrophic destruction. Scholars debate whether Atlantis was purely allegorical, a metaphor for hubris and the fall of societies, or whether it preserves the memory of a real place. What intrigues us is imagining what such a civilization might have looked like before its sudden disappearance. cities stretching across fertile plains, complex waterways channeling rivers into urban centers, towers catching sunlight like mirrors, and machines that hum silently beneath the streets. Then there is Lemuria, a hypothetical lost continent first proposed in the 19th century to explain strange distribution patterns of lemurs and other species in the Indian Ocean region. Though later dismissed as geological myth, it persisted in mysticism and esoteric teachings, imagined as a realm of enlightened beings and forgotten knowledge. Forests once teeming with unknown flora and fauna may have been shaped by intelligent hands. Gardens designed with geometry we no longer recognize. Temples carved into cliffs whose purpose is now lost. Mu, described in Pacific legends, hints at cities swallowed by the ocean, towers crushed beneath waves and technologies erased by tides and time. From mountain plateaus in the Andes to hidden Pacific reefs, myths whisper of beings who walked the earth long before humans recorded their first cities, whose tools, art, and stories are now invisible to the naked eye. Flood myths appear across the globe. Gilgamesh in Mesopotamia, Manu in India, Deucalion in Greece, and countless others in Africa, North America, and the Pacific. Rising waters consume land, reshape continents, and erase settlements. The patterns repeat. Civilizations reaching heights of knowledge and craftsmanship only to be swept away. Layers of silt and sediment preserve traces of these events, pollen, charcoal, and mineral deposits hinting at disturbances that may correspond to catastrophes from times older than human history. Underwater structures like Yonaguni in Japan present sharp edges and geometric forms, prompting questions about erosion versus design. Could such formations hint at the remnants of engineering long submerged? Alongside these are the so-called out-of-place artifacts, found embedded in strata that defy conventional timelines, raising the possibility of lost technology or cultures that predate current records. Symbols and pictographs etched into rock endure where more fragile creations vanish. Petroglyphs may capture images of rituals, tools, or celestial observations, yet their meaning remains hidden. Some may be entirely new discoveries to us. Glimpses of knowledge transmitted across time and simplified through generations, waiting for patterns to be recognized. Consider the relentless forces shaping Earth itself. Volcanoes erupt, glaciers grind mountains into sand, rivers carve valleys anew, and tectonic plates collide, lifting and burying entire landscapes. Metals corrode, wood decays, and plastics disintegrate. Structures that might have once dominated a civilization's horizon now dissolve into layers of stone, leaving traces that require careful scientific sleuthing to interpret. Geochemical and isotopic anomalies provide glimpses into this deep past. Spikes in carbon or rare metals, unusual concentrations of isotopes, and traces of combustion or mining may hint at processes that are difficult to explain naturally. Rocks and sediments may encode a faint record of activity long erased on the surface, offering tantalizing hints of intelligence in epochs we can barely imagine. Footprints, fossilized impressions, and stone formations spark curiosity. Some resemble tools or artifacts that are chronologically unexpected, while others mimic shapes produced by humans yet date far earlier than humanity's known presence. These anomalies invite speculation. What might have created them? And what stories lie hidden beneath the layers of soil and rock? Across continents and oceans, myths and relics interlace. Stories of great floods, lost islands, and golden ages lost to hubris appear repeatedly, suggesting patterns rather than isolated coincidences. As we explore the scattered remnants, ancient stone arrangements, submerged structures, anomalous artifacts, isotopic clues, our attention lingers on the tangible evidence, the concrete hints that invite further exploration and discovery. The narrative stretches into geological formations, ocean sediments, and fossilized landscapes, Mountains may conceal tunnels, valleys may hide remnants of settlement, and coral reefs may cover foundations of cities that no longer exist. Each layer, fossil or metallic anomaly offers a clue, a fragment to study, analyze, and imagine, as investigators of a story written in Earth itself. The exploration continues through symbols, sediment, and the scattered remnants of an intelligence that might have existed millions of years ago. Each discovery raises questions about technology, trade, culture, and environmental management. Even as evidence becomes more subtle, the process of investigation interpreting isotopes, measuring unusual mineral concentrations, examining sediment layers, builds a narrative that stretches across millennia, drawing connections between geology, archaeology, and myth. As we wander further into the deep history of Earth, we enter the world of science, where curiosity meets skepticism, and imagination must walk hand in hand with evidence. For every story of lost lands, sunken continents, and ancient empires whispered in myth, scientists ask the same question: what proof remains? How do we distinguish between legend and reality? Between natural formations and the handiwork of intelligence? The answers are elusive, yet the search itself is endlessly fascinating. Geologists and archaeologists approach the Earth as detectives, studying its layers as a vast archive. Rocks, sediments, isotopes, and fossilized remnants all become clues. Certain chemical signatures can tell stories of environmental upheaval or even industrial activity. If an advanced civilization had existed millions of years ago, it might have left traces in carbon levels, metal concentrations, or unusual isotopic ratios. These would be subtle fingerprints, hidden in the strata of deep time, detectable only to those who know precisely where and how to look. The Silurian hypothesis, proposed by scientists Adam Frank and Gavin Schmidt in 2018, explores a daring question. If an industrial civilization existed long before humans, could we detect it today? Steel corrodes, concrete crumbles, plastic degrades, and stone structures are pulverized by the slow but relentless forces of erosion, glaciation, and tectonic activity. Essentially, the record of any prior civilization would be nearly invisible, leaving only faint chemical traces that might easily be misinterpreted as natural events. Anomalies exist, small hints that provoke curiosity. Scientists occasionally discover unusual objects embedded in ancient layers, metals in coal seams, carved stones in sediments, or traces of unusual compounds where none should exist naturally. While the mainstream explanation usually points to geological processes, contamination, or misdating, the possibility that some of these anomalies hint at ancient intelligence cannot help but spark the imagination. Fossilized footprints offer another intriguing avenue. Most belong to animals, dinosaurs, mammals, and other creatures of deep time. Yet reports occasionally surface of footprints appearing in layers that, according to conventional timelines, should predate humans. Critics argue erosion, sediment shifts, or coincidental patterns. But if a species capable of walking, thinking, and building existed, its impressions could survive in the rock in ways that are subtle, misinterpreted, or overlooked. Meteor impacts and mass extinctions play a role as well. Events like the Permian-Triassic extinction, 252 million years ago, or the Cretaceous-Paleogene extinction, 66 million years ago, reshaped life on Earth dramatically. Cataclysms like these could erase cities, monuments, and even entire populations, leaving only subtle geological traces behind. Fossil records, sediment layers, and isotopic anomalies may contain hints of activity otherwise invisible to the human eye. Archaeological out-of-place artifacts add further intrigue. The London hammer, a metal tool encased in 100 million-year-old rock, is often cited as an example. Mainstream science explains it as a concretion and natural formation of minerals around a modern object, but the structure and composition continue to invite debate. Other anomalies, like metal spheres or carved stones found in ancient strata, similarly fuel speculation about civilizations that may have existed long before humans. Chemical traces in sediments reveal additional possibilities. Layers containing unusual concentrations of carbon, isotopes, or metals may indicate burning, industrial activity, or environmental shifts. Such anomalies, though still debated, create a patchwork of evidence that encourages investigation and exploration of Earth's deeper history. Erosion and plate tectonics continuously reshape the planet. Continents drift, oceans swallow land, mountains rise, and glaciers grind stone to sand. These forces erase most surface evidence over millions of years. Any cities, roads, or monuments older than a few 100,000 years may be gone. Yet microtopographical anomalies, mineral concentrations, and sediment patterns can persist, waiting to be detected. Ice cores and deep-sea sediments preserve environmental records stretching back hundreds of thousands of years. Tiny pockets of air trapped in glaciers, layers of volcanic ash, and chemical signatures in ocean sediments contain snapshots of ancient conditions. Spikes in carbon, unusual metal deposits, or other oddities occasionally appear in these layers, offering potential clues for civilizations that existed long before humans, or for extraordinary natural phenomena that defy immediate explanation. Technology now allows us to peer further into the Earth's hidden past. Satellite imagery, ground-penetrating radar, and isotopic analysis reveal structures and anomalies beneath jungles, deserts, and oceans. Ancient cities or settlements, buried under meters of sand, stone, or silt, could someday emerge from obscurity, revealing details about the activity of species long vanished. Every unusual artifact, chemical anomaly, and enigmatic formation invites investigation. Fossilized objects embedded in rock, patterns of mineral deposition, and unexpected isotopic signatures all become data points in a vast and largely unexplored puzzle. While the evidence is fragmentary and difficult to interpret, the search itself uncovers extraordinary detail about Earth's history and the forces, natural or intelligent, that have shaped it. Imagine a civilization that predates us by millions of years, one whose knowledge and ingenuity rival or even surpass what we possess today. The Earth has witnessed vast stretches of time, and within those spans, the emergence of intelligence could have left subtle fingerprints on the planet, faint but detectable for those who know where to look. What might such a civilization have achieved? And how might their creations have interacted with the natural world? Consider energy. Advanced beings could have harnessed electricity, burned fuels, or tapped geothermal sources, leaving behind traces in sediment chemistry or unusual isotopic ratios. Uranium, thorium, and rare metals might appear concentrated in layers that do not correspond to natural geological processes. Even if cities, power plants, or machines vanished, their chemical signatures might persist as silent markers, waiting for future detection. Construction offers another fascinating possibility. Imagine massive cities built with metals, ceramics, or composites now eroded or transformed. Foundations could have compacted soils differently, altering sediment layering in ways that hint at organized building. Some rock formations across the world display unusual symmetry or straight lines that could suggest design rather than chance, preserved only as anomalies in the landscape. Transportation might have extended across continents. Roads, canals, or bridges could have left depressions, mineralized pathways, or linear patterns in rock, eroded over eons. These features might have facilitated movement of water, food, or materials, allowing the civilization to flourish in ways we rarely imagine for deep prehistory. Streams of transported metals or altered sediments could carry chemical traces, faintly echoing engineered routes that once existed. Communication and record-keeping could also leave subtle hints. Stone carvings may survive, but softened and distorted by time, leaving only grooves, patterns, or symbolic formations. Paper, wood, and clay, if used, would decay, but encoded chemical structures in metals or sediments might remain. Imagined inscriptions, isotopic patterns, or mineral arrangements could serve as unrecognized messages from a vanished intelligence. Agriculture and land manipulation could alter entire ecosystems. Terraced fields, diverted rivers, and deforested plains might leave chemical fingerprints in pollen records or isotope levels. Fossilized crops or domesticated animal remains could hint at deliberate cultivation, even when all visible structures have been erased. Soil layers, enriched with nutrients or altered by irrigation, may preserve subtle evidence of long-gone agricultural techniques. Energy beyond combustion may have been employed. Ancient engineers could have harnessed tides, wind, or even atmospheric phenomena. Volcanoes and earthquakes might have been observed, modified, or mitigated in ways now invisible. Subtle anomalies in mineral deposits, sediment layering, or chemical distribution across oceans could indicate the deliberate influence of beings that understood natural forces at a sophisticated level. Metallurgy offers more traces. Concentrated ores, smelting residues, or alloys embedded in sediment might be misinterpreted as natural formations. Copper, bronze, iron, or rare alloys could survive as isolated anomalies, detectable only with precise scientific methods. Patterns of extraction or use could be encoded in mineral deposits, revealing purposeful manipulation of Earth's resources. Art and culture might persist as microtraces. Pigments in stone, impressions in hardened clay, or microstructures in minerals could survive as faint echoes of artistic expression. Geometric designs, symbolic carvings, or intentional arrangements of stone could hint at cognition and creativity, even when the original purpose is lost. Sculptures or tools might disintegrate, yet residues in rocks or sediments could preserve the intention behind them. Environmental consequences would also linger. Large-scale civilizations change their surroundings. Deforestation, erosion, or shifts in atmospheric composition might leave chemical anomalies detectable in ice cores, sediment layers, or fossilized pollen. Even without structures or artifacts, these environmental signatures could indicate intelligent activity, subtly rewriting the biological and chemical history of Earth. Inventions and tools could leave microscopic traces. Engineered minerals, unusual alloys, or crystalline structures embedded in sediment might persist when physical machines have vanished. Nanostructures or isotopic irregularities could reveal manipulation of matter and energy, hinting at technology whose full scope we can only imagine. The deeper we examine these possibilities, the more intricate the scenario becomes. Each trace, each anomaly, whether chemical, geological, or fossilized, opens new doors into what might have existed. Metal anomalies in sediment, isotopic oddities, altered ecosystems, and mysterious formations could all mark the presence of an intelligence far older than humans, leaving hints of activity that continues to challenge conventional understanding of Earth's deep past. As we dive deeper into the possibility of civilizations predating humans, our attention turns to the curious and often controversial world of mysterious artifacts, objects that appear where and when they seemingly should not. These out-of-place artifacts, or OOPArts, challenge conventional timelines and ignite the imagination, forcing us to consider whether our understanding of history is as complete as we think. One of the most famous examples is the London Hammer, discovered in Texas and encased in rock dated to approximately 100 million years old. Mainstream science argues that the rock formed around the hammer through natural concretion. Yet the very idea of a tool embedded in stone of that age sparks wonder. If genuine, it would suggest intelligence using tools tens of millions of years before humans evolved. A timeline so staggering it reshapes everything we assume about early civilizations. Another remarkable case comes from South America. Carved stones and metallic objects found in layers of sediment that, according to geological dating, should predate known human activity. While most are dismissed as misinterpretations or hoaxes, repeated reports over decades demand attention. The objects display intricate craftsmanship, precise carvings, polished surfaces, and geometric patterns that hint at knowledge and dexterity lost to time. Fossilized tracks and impressions push the boundaries even further. Human-like footprints have been reported in strata containing dinosaur fossils in locations such as Texas, Pulaski River, and parts of Turkey. Skeptics cite erosion or coincidental natural formations, yet the sheer number and detail of these impressions suggest deliberate investigation. The tracks show arches, toes, and step patterns that match human anatomy, forcing us to consider the unimaginable. A civilization living alongside species previously thought incompatible with human presence. Tools and metallurgy present their own enigmas. Ancient objects made of bronze, iron, and alloys occasionally surface in strata far older than expected. Some show evidence of advanced shaping, casting, or polishing techniques. Even if modern intrusion explains a few, the sheer frequency of anomalies raises questions. Could these be remnants of lost industries? Hints of a civilization manipulating materials with knowledge that has since disappeared? Intricate stone structures add another layer of intrigue. Göbekli Tepe in Turkey, Beigong pipes in China, and the megaliths of Easter Island demonstrate alignment with celestial bodies, advanced engineering, and an understanding of geometry that seems sophisticated for their era. The precision of these structures implies a legacy of architectural knowledge, possibly passed down or inspired by memory of an older, forgotten civilization. Deep-sea sediments reveal further mysteries. Metallic spheres, unusual formations, and artifacts embedded in rock millions of years old occasionally emerge from the ocean floor. The natural explanations often dominate, yet anomalies remain. Some of these objects suggest intentional shaping, placement, or function, hinting at civilizations capable of creating durable objects that withstand geological processes and submersion beneath rising seas. Meteorites and impact craters provide a cosmic twist. High-energy impacts could have coincided with ancient civilizations, erasing surface evidence while leaving isolated artifacts behind. Unusual metal concentrations, compressed layers of sediment, or rare chemical isotopes might mark the interaction of intelligent activity with natural cataclysms, leaving cryptic traces for modern investigators to uncover. Fossilized remains themselves sometimes carry hints of manipulation. Bones arranged with geometric precision, stones stacked in unnatural patterns, or chemical alterations in organic matter suggest intelligent intervention. The evidence is subtle, often contested, yet the anomalies cannot be dismissed entirely. They hint at activity occurring in time periods we previously assumed were dominated only by natural forces. Symbols, carvings, and inscriptions offer further intrigue. Petroglyphs, cave paintings, and carvings in stone occasionally show geometric patterns or figures that defy easy interpretation. Some align with astronomical events. Others display repeated motifs across distant regions. Mainstream archaeology often situates them within known cultures, yet anomalies persist, enigmatic shapes, lines, or arrangements that seem out of place, pointing toward knowledge transmitted across epochs. Layer upon layer of anomalies, artifacts, footprints, megaliths, chemical traces, and symbols creates a landscape of questions stretching across deep time. Each object, each imprint, each structural alignment invites investigation, demanding careful observation and imagination. From deserts and rivers to the ocean floor, from stone pillars to metal spheres, the evidence suggests that the Earth may harbor countless traces of intelligent activity that predate our earliest records. The world itself becomes a puzzle, scattered across geologic time, each fragment beckoning researchers, explorers, and dreamers to uncover mysteries hidden beneath stone, sand, and sediment. As we explore the possibility of civilizations that existed long before us, we must consider not only physical artifacts but also knowledge ideas, science, and technologies that might have been lost to the ages. The Earth has witnessed unimaginable spans of time, and civilizations rising and falling in that vast expanse could have achieved understanding and innovation far beyond what we commonly attribute to ancient peoples. Imagine the ruins and machines hidden beneath sediment, buried cities stretching under oceans, or networks of trade routes lost to shifting continents. Take engineering, for instance. The precision of some ancient stone structures challenges modern expectations. Megalithic sites around the world, including Stonehenge, Karnak, and the pyramids of Giza, demonstrate knowledge of mathematics, geometry, and astronomy that seems extraordinary even by today's standards. Massive stones weighing tons were quarried, transported, and assembled with exacting alignment to celestial events. Techniques for moving such stones, building stable structures, and enduring natural disasters may hint at skills developed long before recorded history. And remnants of tools or foundation trenches might still lie hidden under millennia of soil. Mathematics itself may carry hidden traces. Complex numerical systems, calendars, and ratios could have been discovered, recorded, and applied in ways that predate known civilizations. Evidence may survive in monuments, stone carvings, or symbolic arrangements whose meaning is obscured. Could the layout of certain ancient cities, streets, or ceremonial spaces encode mathematical principles passed down from even older societies? Every carved line, every geometric alignment, becomes a clue in a puzzle that stretches across eons. Consider the study of astronomy. Ancient civilizations worldwide tracked the skies, marking solstices, equinoxes, and planetary positions. Structures aligned to stars, lunar cycles, or eclipses could indicate inherited astronomical knowledge from predecessors who observed celestial patterns over long periods. Shadows falling along carefully arranged stones at precise times, subtle adjustments in temple orientation, or arrangements of artifacts in observatories might preserve knowledge too advanced to fully understand without context. Metallurgy offers another tantalizing window. Ancient alloys, objects resistant to corrosion, or metals found in geological layers older than known human activity suggest expertise that may have vanished entirely. Smelting, shaping, and chemical processing techniques might have been far ahead of their time, with fragments of tools, furnace remains, or slag deposits waiting to be discovered. Advanced metal objects embedded in sediments could be signals of complex production systems, long forgotten, but traceable through microscopic examination. Water management and urban planning also leave subtle clues. Ancient civilizations may have built terraced landscapes, canal systems, aqueducts, or subterranean networks designed to regulate floods, irrigation, or drainage. Structures could have been buried by shifting soils, volcanic ash, or rising seas. Fossilized riverbeds, unusual sediment distribution, or remnants of engineered terraces may hint at large-scale organization, agricultural planning, and societal coordination long before recorded history. Energy harnessing could have taken forms we cannot yet imagine. Mechanical devices powered by water, wind, or gravity might have existed. Geological anomalies, mineral pattern disruptions, or sediment disturbances could reveal early experimentation with energy use. Even traces of heat-altered rocks or charcoal concentrations could indicate industrial processes previously unknown, leaving subtle signatures across landscapes or buried strata. Writing and symbolic communication may have existed in forms now lost. Materials like wood, plant fibers, or early composite papers decay rapidly, but surviving indirect evidence could appear in carvings, abstract patterns, or arranged artifacts. Systems of encoded information might persist in rock formations, artifact alignment, or symbols, waiting to be interpreted. Complex networks of communication and record keeping could leave fingerprints in ways we are only beginning to detect with modern analytical techniques. Scientific exploration likely extended to chemistry, medicine, and engineering. Chemical traces in sediments, residues from controlled fires, or unusual compounds may hint at processes developed millions of years ago. Fossilized materials, altered soil composition, and mineral deposits could reveal experimentation with alloys, energy, or resource management. The arrangement of artifacts, stone formations, or isotopic anomalies might suggest advanced technological application across wide areas. Trade and exploration may have shaped entire continents. Routes connecting distant regions, isotopic signals and artifacts, or similarities in construction methods across geographies may indicate networks of exchange. Raw materials, metals, and crafted objects could have moved thousands of miles, with sediment traces, unusual mineral concentrations, or buried artifacts providing glimpses into trade and cultural interaction. The imagination itself can leave clues. Myths, legends, and symbolic art might encode observations of natural phenomena, scientific principles, or technological processes in allegorical or abstract forms. Rock art, carvings, and symbolic arrangements may preserve encoded understanding of physics, astronomy, or engineering, offering subtle hints about civilizations that existed far earlier than we can currently document. As we continue imagining civilizations that predate recorded human history, it is natural to explore the scale of their impact. Civilizations leave marks on the world not only through buildings and artifacts, but also through subtle, pervasive interactions with their environment. From reshaping landscapes to influencing ecosystems, the traces of an ancient civilization could be etched into the very geology of the Earth, waiting to be detected in sediment layers, mineral anomalies, and fossilized remnants. Landscapes today often carry faint signatures of human activity. Terraces, canals, and altered river courses. Now, envision similar interventions, but from civilizations millions of years older. Even if cities, monuments, and machinery were obliterated by erosion, glaciers and tectonic movement, shifts in soil composition, unnatural layering of sediments, or unusual mineral deposits might hint at purposeful environmental engineering beyond what we currently recognize as artificial. Water systems might have been manipulated on an impressive scale. Rivers redirected, lakes drained or created, coastlines altered to sustain populations or agriculture. Over millions of years, sedimentation could bury these features, yet subtle alignments, unusual sedimentary structures, or isotopic anomalies in water deposits could betray their existence. Aqueducts, canals, or reservoirs from deep time may have been completely erased, leaving only chemical or physical alterations behind. Land management and deforestation would also leave enduring traces. Large-scale clearing for agriculture, settlement, or resource extraction could alter soil composition, erosion patterns, and even local climate. Forests may regrow and landscapes reshape themselves over millions of years, but pollen patterns, charcoal residues, or carbon isotope variations might persist in geological cores, hinting at intelligent manipulation of ecosystems long before humans emerged. Agricultural practices might leave isotopic fingerprints in the soil. Enrichment through cultivation or mineral addition could differentiate altered plots from untouched land. Fossilized plant remains might reveal species cultivated out of natural timelines, while subtle signs of altered biodiversity, shifts in animal populations, or changes in plant growth patterns could suggest environmental influence by intelligent mining and resource extraction offer another lens into ancient activity. Exploitation of metals, stone, or other resources could leave subtle traces in the geological record. Metal concentrations out of place, smelting residues, or unusual rock formations might survive, while chemical and isotopic studies could reveal anomalies that challenge purely natural explanations. Energy production may have left faint yet detectable marks. Combustion, geothermal use, water-based systems, or other technological processes could have altered the chemical composition of soils, sediments, or atmosphere. Carbon, metal, and elemental concentrations in sediment layers could reflect activity beyond natural processes, hinting at industrial-scale operations in the distant past. Urban planning and settlement patterns might also be encoded in the Earth itself. City layouts, roads, and transportation networks compress soil, redistribute sediments, and produce long-term topographical changes. Tectonic movement and erosion could erase visible evidence, yet microtopographical variations, anomalies in sediment density, or aligned stone formations might persist as subtle hints of large-scale organization. Volcanic and seismic regions could preserve unusual signatures of human-like activity. Large-scale environmental modification might include harnessing natural forces, diverting rivers, or building protective structures. Sediment deposition patterns, mineral concentrations, or structural anomalies in tectonically active zones may hold traces of interventions waiting to be studied. The oceans and coastlines might carry their own fingerprints. Sunken cities, altered tidal patterns, and sediment disturbances could leave subtle clues. Ocean cores sometimes reveal chemical anomalies, shifts in plankton populations, or unusual mineral deposits that suggest the activity of intelligent life long before humans. Marine ecosystems, sediment layers, and submerged geological features might hold fragments of deep-time civilizations, hidden beneath layers of water and stone. Civilizations acting across multiple regions could create a patchwork of detectable influence. Land, water, and ecosystems all bear potential traces. Isotopic anomalies, sedimentary patterns, fossilized environmental changes, and unusual geological structures may interconnect to form a scattered record of intelligence. Each trace, small and often overlooked, adds a piece to a picture of planetary scale modification and engineering, stretching the imagination towards civilizations lost to time. As we imagine civilizations that existed long before recorded history, it becomes natural to wonder whether multiple intelligent societies could have coexisted on Earth simultaneously. A single civilization, no matter how advanced, is only one thread in the vast tapestry of possibility. Across continents and oceans, networks of knowledge, trade, and cultural exchange might have crisscrossed landscapes, long before humans recorded their first histories. Ideas could have traveled along rivers, across deserts, and over mountains, leaving faint impressions in the land itself. Geography would have shaped these interactions in fascinating ways. Millions of years ago, continents were not as we know them today, connected by land bridges that now lie beneath the sea, or separated by vast oceans that have since shifted. Fertile plains now buried under deserts may have hosted thriving settlements, while mountain ranges, now eroded to rubble, might have once been home to civilizations whose structures were aligned with peaks or valleys. Travel could have been accomplished along rivers, on rafts or early boats, or even over frozen expanses, leaving traces in sediment layers and unusual mineral distributions. Artifacts from distant regions occasionally share striking similarities, raising questions that hint at contact or shared knowledge. Megalithic structures, elaborate carvings, and geometrical patterns appear across continents separated by oceans, their recurrence prompting speculation. Are these merely convergent coincidences, Or could they represent echoes of a shared understanding inherited from an earlier civilization? Tracing these connections could reveal networks of communication and cultural influence, stretching across lands now considered isolated. Language and symbolic communication offer further intrigue. If multiple civilizations developed independently, they may have cultivated unique systems of symbols, art forms, or proto-writing. Yet when interactions occurred, these languages and symbols might have converged in intriguing ways, especially around technology, rituals, or shared cultural practices. Inscriptions etched into stone or arrangements of artifacts could be remnants of communication, still faintly resonating in patterns waiting to be interpreted. Trade may have extended far beyond local territories. Metals, minerals, crafted tools, or even cultivated plants could have traversed vast distances, leaving behind subtle isotopic or chemical traces in the earth. Exotic materials appearing outside their natural sources suggest deliberate movement, hinting at the complexity of exchange networks. Plants and domesticated species may have been transported for food, medicinal purposes, or ceremonial use, linking regions that today seem disconnected by geography or time. Knowledge transfer could have shaped the development of civilizations, allowing ideas in metallurgy, energy harnessing, or engineering to spread from one society to another. Techniques for constructing durable buildings, developing irrigation, or navigating landscapes could diffuse subtly, leaving evidence in the form of unusual mineral deposits, patterns in stone, or remnants of structures. As civilizations rose and fell, these traces might persist, scattered and enigmatic, woven into the land and rocks. Conflict and cooperation likely influenced how civilizations evolved. Territories may have been defended, alliances forged, and resources contested, leaving marks in fortifications, trenches, or altered landscapes. Controlled use of fire, defensive earthworks, or concentrations of material artifacts could indicate strategic planning and organized activity. These features, even when eroded or buried, act as silent testimonies of interactions between societies and hint at patterns of behavior that echo through deep time. Cultural practices and rituals may have been inscribed on the landscape itself. Ceremonial sites, temples, or symbolic stone arrangements could have aligned with celestial events, seasons, or geographic markers, encoding knowledge in physical form. Unusual mineralization, precise placement of stones, or abstract patterns might suggest deliberate, intelligent design, leaving artifacts that persist even as buildings and cities crumble under geological forces. Environmental management could reveal layers of intelligence interacting with ecosystems. Civilizations might have coordinated land use, redirected rivers, or managed resources in ways that altered soils, vegetation, or animal populations. Sediment cores, fossil records, and isotopic analyzers could reveal these patterns, showing deliberate interventions that shaped environments and created lasting, though subtle, signatures of intelligent activity. Knowledge may have survived in indirect, enigmatic forms. Stories, myths, symbolic carvings, and repeated motifs across distant cultures could preserve fragments of information about lost civilizations. Patterns in rock art, ceremonial objects, or recurring symbols may encode technical knowledge, ecological understanding, or cultural memory. Each artifact, each unusual formation, acts as an open-ended clue, inviting continued exploration and discovery without ever fully revealing the scope of what once existed. Imagine a civilization millions of years before humans, sprawling across fertile plains with cities of stone and metal, its people shaping rivers, building roads, and cultivating vast lands. Tectonic plates shift beneath their feet, lifting mountains and splitting valleys. Earthquakes crack the foundations of monumental structures, throwing stone blocks across streets and collapsing walls with thunderous force. Lava spills from distant volcanoes, flowing slowly and steadily at first, then surging with unstoppable heat across towns, consuming forests, homes, and fields of crops. Ash clouds rise, drifting over distant lands, darkening the skies, and covering the world in a fine grey blanket. Rivers, once calm, surge and change course as land tilts or crumbles. Floods consume settlements near the banks, sweeping bridges and docks into turbulent currents. Lakes that supplied water to entire regions overflow, turning fertile fields into marshlands. Coastal cities vanish beneath rising seas, waves crashing into walls, tearing apart piers and carrying debris miles inland. Tsunamis roar across continents, leaving strange patterns of stones and sediment, submerging human constructions under layers of sand and silt. Glaciers advance across plains, grinding soil and rock, carrying remnants of forests, roads, and buildings along with them. As ice moves, it scours mountainsides, exposing bedrock, stripping away settlements, and depositing jagged boulders over long-forgotten fields. The slow, relentless movement of ice alters rivers and valleys, carving new landscapes that mask what once existed. Snowstorms batter cities, freezing rivers solid, encasing structures in ice, while avalanches sweep through valleys with crushing force, burying every trace of human labor. The atmosphere itself shifts, temperature swings becoming extreme. Droughts scorch fields, drying wells and causing famine. Storms rage with violent winds, tearing roofs from buildings and uprooting trees that once shaded towns. Volcanic eruptions darken the sky for months, reducing sunlight and forcing crops to fail across entire regions. Rain falls in acidic torrents, dissolving metals, eroding stone carvings, and washing away soil layers that could preserve evidence of cultivation. Meteor impacts strike oceans or land with explosive force. Craters form, reshaping mountains, flattening forests and vaporizing lakes. Fires ignite over vast areas, consuming forests, grasslands, and human settlements. Debris hurled into the atmosphere alters climate, creating a cycle of storms, heat, and cold that challenges any civilization's survival. Ash and dust drift for years, settling in layers, covering cities, roads, and fields, leaving chemical traces that endure while structures vanish. Erosion works quietly yet persistently, with wind, water, and heat reshaping stone walls and sculpting landscapes. Streets crumble into dust, temples erode to rubble, and monuments once erected to honor leaders and gods lose their shape. Rivers carve new channels, carrying fragments of civilization into sediment layers that mingle with natural debris, hiding the presence of intelligent activity from all future observers. Seas and oceans consume lands over millennia. Rising tides flood coastal cities, currents scatter artifacts, and sedimentation buries ports under sand and silt. Coral grows over submerged structures. Marine life colonizes human-made materials, and chemical reactions slowly corrode metals and dissolve carvings. Sunken buildings collapse under water pressure, leaving only subtle shifts in the seabed, patterns invisible without modern technology. Even biological forces reshape the remnants of civilization. Forests reclaim abandoned lands, animals graze where crops once grew, and natural succession covers roads and fields with vegetation. Decay transforms wood, textiles, and other perishable materials into unrecognizable remnants, leaving only durable stone or metal traces to be hidden beneath layers of earth. Volcanic, tectonic, oceanic, and cosmic forces intertwine to create a world where no structure remains untouched. Earthquakes twist foundations, lava flows coat valleys, glaciers grind plains, Storms scour mountains and asteroids leave impact craters filled with chemical signatures. Minerals shift, layers mix, and sediment accumulates, hiding what once thrived on the surface. Even the most advanced civilizations, with knowledge of energy, engineering, and environmental management, contend with these forces simultaneously. Lands are reshaped, waters redirected, mountains grow and crumble, and cities vanish beneath ice, lava, or ocean currents. Traces persist in subtle ways: chemical anomalies, altered sediments, or rare artifacts, while the civilization continues to dissolve into the planet's ever-changing surface, existing only in the interplay of natural forces. Imagine walking across a landscape that has been untouched by humans for millions of years. At first glance, everything seems natural. Rolling hills, riverbeds, and forests. Yet beneath the surface, subtle anomalies hint at activity that predates humanity. Geological layers hold secrets in their composition, in patterns of sedimentation, and in unusual concentrations of metals and minerals that do not align with natural processes. Rocks can whisper stories of intelligence, if only we know how to read them. Sedimentary layers reveal irregularities that spark curiosity. Certain strata contain materials that normally would not coexist, such as metals or ceramics deposited alongside fossils or volcanic ash. Tiny isotopic signatures in these layers suggest processes requiring deliberate manipulation, heating, smelting, or chemical reactions that naturally occurring systems cannot produce. Soil chemistry preserves traces of cultivation or settlement, with nutrient levels, carbon content, or mineral ratios differing sharply from surrounding terrain. Fossil evidence can carry unusual hints. Occasionally, plants or animals appear outside their expected evolutionary timeline, raising questions about deliberate transplantation or domestication. Fossilized seeds or plant matter showing signs of cultivation or selection suggest interaction with the environment. Patterns in animal fossils, such as unexpected herd distributions or selective hunting, hint at ecological knowledge and management. Rock formations sometimes retain clues to past intelligence. Carvings, structures, or alignments that seem geometric or regular survive in altered or mineralized forms. Erosion blurs edges, yet precise angles, symmetrical arrangements, or consistent spacing stand out against chaotic natural formations. Geologists occasionally encounter features in bedrock that defy conventional explanation, raising questions about possible intelligent intervention. Chemical anomalies persist in subtle ways. Elevated concentrations of copper, aluminum, or rare earth metals in isolated layers may indicate mining, smelting, or construction activity. Charred organic materials, burned sediments, or traces of ancient combustion hint at energy use or industrial processes. Corroded metals and crumbled structures leave behind chemical footprints that survive in rock layers. Water systems carry delicate evidence of ancient manipulation. Canals, reservoirs, or aqueducts collapse over time, but disturb sediment patterns in ways natural rivers rarely replicate. Erosion, deposition, and mineral layering in dried lake beds, river deltas, or coastal plains may reveal artificial modification. Isotopic composition in water deposits can hint at systematic storage or usage, potentially centuries or millennia before humans. Volcanic layers sometimes encode traces of activity. Lava flows, ash deposits, and pyroclastic materials may contain pockets of metals, ceramics, or altered rock, suggesting interaction with heat or technology. Glacial sediments preserve anomalies where boulders or debris appear transported against natural glacial patterns, or where soil layers contain materials inconsistent with known flora, fauna, or deposition timelines. Microfossils offer additional clues. Pollen grains, spores, and microscopic organisms embedded in sediment layers indicate selective planting, deforestation, or ecosystem manipulation. Sudden appearances of cultivated plants in unexpected regions hint at intelligent environmental influence. Patterns that seem random at first glance may reveal intentional shaping of landscapes or resources. Artifacts, when they survive, are often fragmented or obscured. A metal fragment, carved stone, or ceramic shard may remain encased in rock, its context hidden. Modern analysis, X-ray scanning, chemical assays, and microscopic examination can uncover anomalies invisible to the naked eye. Compressed sediment layers may contain tiny hints, aligned stones, metallic traces, or residues suggesting the presence of long-lost civilizations. Even landscapes that appear entirely natural can contain subtle patterns hinting at design. Terraces, channels, or aligned formations resist explanation through ordinary geological processes alone. Combined with chemical, fossil, and mineral evidence, these anomalies suggest complex interaction with the environment. Every soil sample, every rock layer, and every trace element offers a fragment of a larger puzzle, an ongoing mystery of intelligence and activity etched into the earth long before humans arrived. Imagine walking through the ruins of a civilization that existed millions of years before humans. A society capable of shaping its environment with intelligence and precision. Massive stone and metal structures stretch across landscapes, some buried beneath layers of sediment, others partially eroded by wind and water. Advanced metallurgy gleams faintly in traces of alloys that resist corrosion and extreme temperatures. Metals shaped with techniques lost to time. Tools and machinery, scattered or buried, hint at construction methods, agricultural systems, or energy generation processes, leaving mineral deposits or unusual chemical signatures as the only signs of wind and water channels appear carefully engineered, suggesting early energy harnessing. Turbines, water wheels, or mechanisms carved into bedrock may have converted natural forces into mechanical power. Heat-treated minerals, glass fragments, and ceramics are embedded within ancient sediment, evidence of energy-intensive activities like smelting, firing, or manufacturing. Geothermal vents might have been tapped for warmth or industrial processes, with stonework around these sites showing evidence of controlled heat application and structural planning. Visual communication systems rise from the landscape. Towers, elevated platforms, and geometrically aligned stones may have transmitted information across vast distances. Patterns in stone arrangements could encode instructions, calendars, or astronomical data. Observatories or sightlines aligned with solstices, equinoxes, or star patterns hint at precise observational knowledge, providing guidance for agriculture, navigation, or ceremonial events. Construction methods display intricate design. Stone blocks carved with precision, metal frameworks interwoven with composite materials, and foundations aligned to resist earthquakes or erosion suggest advanced engineering. Fractured stone surfaces, unusual cut angles, and remnants of scaffolding indicate deliberate architectural planning. Foundations may span miles, linking urban centers with ceremonial or industrial zones, while partially buried structures hint at urban density and complex spatial organization. Transportation networks stretch across continents. Roads, bridges, and canals carved into the earth suggest systematic movement of resources and people. Sediment disruptions, aligned rock formations, and traces of ancient ports indicate that waterways were crucial arteries for commerce, travel, and cultural exchange. Craft remains, possibly seafaring vessels or riverboats, imply navigation of lakes, rivers, and even open seas, connecting settlements separated by hundreds of miles. Agricultural innovation appears in soil layers. Fossilized crops, pollen concentrations, and nutrient anomalies in sediment suggest deliberate cultivation, soil management, and irrigation. Terraces, canals, and reservoirs hint at water control for consistent yields. Evidence of selective planting, domesticated plant species, and managed landscapes shows that food production was carefully planned, sustaining dense populations and complex social organization. Artistic and symbolic expression permeates stone and metalwork. Carvings, intricate sculptures, and geometric designs encode patterns that might reflect astronomical knowledge, mathematical understanding, or spiritual practice. Abstract arrangements of rocks, minerals, or fossil fragments could act as mnemonic tools, cultural markers, or communication devices, each hinting at a layered civilization where art and utility intertwine. Medical and biological understanding leaves faint but telling traces. Fossilized bones with signs of healing or intervention, manipulated plant remains, and carefully modified habitats suggest knowledge of anatomy, disease, and health management. Chemical residues in soils hint at preparation of herbal remedies, controlled burns to manage pests, or cultivation of medicinal plants for community use. Evidence of energy experimentation appears sporadically. Minerals shaped unusually, cavities in stone with metallic residues, and patterns in sediment could suggest attempts to store or manipulate energy. Devices that once held chemical, thermal, or mechanical potential may have been part of laboratories or workshops, indicating a sophisticated engagement with physical forces long before humans developed similar technology. Leisure, observation, and intellectual pursuit coexist with utility. Stone arrangements align to celestial events, patterning in minerals, and potential craft areas suggest engagement with knowledge for curiosity and aesthetic pleasure. Tools for exploration, measurement, or artistic creation appear alongside functional technology, showing a civilization attentive to both survival and intellectual enrichment, bridging practicality and curiosity in ways that hint at a complex and vibrant culture. Picture a civilization so ancient that the stars, the moon, and the sun guided every aspect of their existence. Long before humans charted constellations or built observatories, they may have looked skyward with keen curiosity, noticing patterns, cycles, and subtle changes across decades, centuries, and even millennia. The night sky could serve as a calendar, a map, and a spiritual guide all at once, providing a framework for daily life, survival, and ceremony. Imagine vast open spaces where communities gather to observe celestial events. Across plains, plateaus, or deserts, generations of people might record the rise and fall of constellations, the shifting path of the sun, or the rhythmic motion of the moon. Observations passed down through song, story, and symbolic markers etched into stones or carefully arranged across landscapes. Each observation builds a growing knowledge, informing planting schedules, hunting patterns, and migration planning, creating a living record of the sky written in stone, soil, and shadow. Large stone structures could align precisely with solstices and equinoxes. Circles of massive stones, elongated corridors of carved rock, or pits dug into bedrock may catch sunlight or shadows at specific times of the year, creating monumental calendars or ceremonial spaces. Some structures may frame the first light of dawn or the last glow of twilight on important days, reflecting an understanding of celestial mechanics that could endure through millennia. The planets themselves might be tracked with meticulous attention. Movements of Venus, Mars, or Jupiter could be recorded using shadows, stones, or symbolic markers, allowing ancient observers to anticipate seasonal changes, river flooding, or animal migrations. Patterns repeated over generations could create predictive systems, turning the sky into a complex repository of practical and spiritual knowledge. Lunar cycles may have guided ceremonies, agriculture, and social organization. Full moons, eclipses, and phases of the moon could determine rituals or planting times, while structures oriented to capture moonlight during specific phases reinforce the connection between civilization and celestial rhythm. Multiple generations observing and adjusting to the subtle motions of the moon would create precise, long-term records encoded in monuments, carvings, and ceremonial layouts. Comets, meteor showers, and cosmic phenomena would inspire both awe and practical observation. Rare events might be interpreted as omens or as lessons, marked in rock formations or arranged stones. The ability to detect repeating patterns in seemingly random events reflects patience, intelligence, and an intimate knowledge of the heavens, hinting at a culture deeply attuned to both terrestrial and cosmic environments. Navigation could rely heavily on the stars. Communities near rivers, coastlines, or vast plains might track the positions of specific stars to orient themselves across long distances. Seasonal shifts in star positions could function as a natural compass, guiding explorers, traders, and migratory populations. Celestial observation becomes intertwined with survival, enabling people to move efficiently across terrains with few natural landmarks. Art and symbolism could encode astronomical knowledge. Carvings, murals, or arrangements of objects might depict planetary movements, solar cycles, or constellations. Even abstract patterns could record temporal, navigational, or agricultural data. Faint geological anomalies, geometric alignments, or chemical residues in rock and mineral layers might preserve these insights, offering subtle evidence of a civilization that engaged deeply with the cosmos. The intersection of astronomy and agriculture could be vital for survival. Knowledge of seasonal changes, shadow lengths, or sun angles might dictate planting and harvesting cycles, the migration of domesticated animals, or water management strategies. Shadows cast by monuments or natural features could act as primitive calendars, marking crucial dates with precision and encoding knowledge across generations. Even philosophical and spiritual thought might intertwine with celestial observation. The motions of the sun, moon, and planets could symbolize cycles of life, death, and renewal. Rituals may align with celestial events, while symbolic carvings translate astronomical understanding into art, belief, and community organization. Science, observation, and spirituality merge seamlessly, creating a culture where knowledge of the heavens informs practical life, ritual practice, and philosophical reflection in ways lost to history, but potentially encoded in stone, soil, and shadow. Imagine walking through a sprawling city millions of years before humans, sunlight glinting off towering stone structures, metal frameworks, and curious constructions that twist in ways both practical and ceremonial. Everywhere you look, there are signs of organized thought. Symbols etched into walls, carvings on monoliths, and deliberate arrangements of objects communicate across spaces, guiding anyone who knows how to read them. Every alleyway, plaza, and chamber hums with information, patterns of logic and design encoded in architecture itself. Perhaps people gather in ceremonial spaces to share knowledge, using gestures, songs, and visual codes to teach astronomy, engineering, or medicine. Elders trace river flows with sticks in the sand, demonstrating irrigation patterns or predicting seasonal changes. Children study the alignment of stones with the moon, or track the sun across specially marked courtyards. Traders leave symbols along riverbeds or open plains, encoding safe routes, hazards, and the locations of resources. Each mark or arrangement is subtle yet precise, a language of observation and interpretation preserved across generations. Symbols and carvings might serve as a universal language, carefully crafted to survive long spans of time. Circles, triangles, spirals, and interlocking geometric patterns could encode complex ideas, from seasonal calendars to navigational routes. Shadows cast at precise moments might animate these carvings, transforming static symbols into dynamic storytelling mediums. Light and motion become carriers of knowledge, allowing understanding to emerge from careful attention to natural rhythms. Communication may extend across long distances. Stone markers, standing in alignment with rivers or ridges, could function like signposts, transmitting information to travelers. Reflections from polished surfaces or intermittent fires on hillsides could carry alerts and coded messages far beyond the reach of a single voice. Imagine observing a signal bounce across valleys, a pattern of light conveying instructions or warnings to anyone trained to interpret it. Even underground, tunnels and chambers might carry meaning through acoustic properties. Sound reverberates along carefully designed corridors, allowing vibrations or tones to indicate different sections, functions, or signals. Some chambers may be structured for multiple purposes, storing artifacts, carrying messages, or conducting ceremonies where echoes, chants, and percussion encode knowledge in sound. Architecture itself acts as a medium of communication. Everyday objects could contain encoded information. Tools, pottery, or ornamental items might display markings indicating purpose, ownership, or procedural instructions. Handles etched with symbols show usage. Pigments embedded in ceramics convey numeric or seasonal data, and the placement of items in homes or ceremonial spaces could transmit subtle messages regarding timing, status, or ritual significance. Objects are functional and communicative simultaneously. Trade and diplomacy likely rely on both symbolic and practical systems. Envoys may transport carved tablets, arranged artifacts, or coded items as records of agreements, resources, or instructions. Over time, some objects become mineralized, others chemically altered, leaving traces in protected sediment layers. Future observers encountering anomalies in these layers may detect deliberate design hinting at sophisticated communication and planning. Storytelling may intertwine seamlessly with record keeping. Events such as migrations, floods, or unusual natural phenomena could be encoded in patterns of stones, sequences, or carvings. Oral traditions complement these physical markers, allowing stories to travel through space and time, adapted slightly by each generation, yet preserving functional knowledge about survival, environment, and culture. Celestial observation could reinforce terrestrial communication. Alignments of stones, reflective surfaces, and carvings interacting with solar, lunar, or planetary positions convey messages about seasonal cycles, agricultural timing, and ceremonial dates. Knowledge of the stars becomes a language connected to the land, enabling prediction, planning, and coordination across distances. Every wall, carving, and arrangement of stone or metal contributes to the functioning city as a living system of encoded knowledge. Courtyards, streets, and plazas carry instructions, guidance, and cultural meaning. Light, shadow, and sound animate these symbols, creating a layered network of understanding that spans space, time, and function. The city thrives as a network of information. Each mark, alignment, or artifact a node in a vast web of intelligence, constantly interacted with by those who know how to read it. Imagine a civilization so ancient that rivers, mountains, and plains were as much part of their design as the cities they inhabited. They studied the land with meticulous care, observing the flow of water, the movement of wind, the cycles of the sun, and even the migration patterns of animals. From this understanding, they engineered landscapes to serve their needs, carving canals to redirect rivers, terracing hillsides for agriculture, and building dams and reservoirs to manage water across vast regions. Their interventions were precise, blending functionality with harmony, each structure designed to complement the natural terrain rather than dominate it. Picture a sprawling city beside a winding river, streets following the natural contours of the land, while massive aqueducts channel water to public fountains, gardens, and workshops. Stone channels wind across fields, regulating irrigation with precision that rivals modern techniques, while small boats traverse canals, carrying goods, minerals, and messages along networks that stretch for hundreds of miles. Every turn of water seems deliberate, every drop guided by a mind that understood not only physics, but the balance between human needs and environmental limits. Bridges rise elegantly from riverbanks, constructed with interlocking stone or metal frameworks, some spanning lengths that challenge contemporary engineering. These structures bear the weight of travelers, carts, and watercraft while directing currents, preventing flooding and integrating with surrounding ecosystems. The stone and metal, carved and joined with uncanny precision, suggest an advanced understanding of stress, geometry, and materials science that is difficult to imagine for a civilization predating modern technology. Roads extend outward like arteries from the city center, designed for efficiency and durability. Paved pathways, lined with carved markers or stone posts, guide travelers across hills, valleys, and forests. Strategic placement of settlements near quarries, fertile soil, and mineral deposits reflects not just planning, but a sophisticated knowledge of geology. The routes themselves may follow subtle contours, avoiding erosion-prone areas, optimizing drainage, and even considering seasonal weather patterns that could affect travel and trade. Terraces climb steep hillsides, each layer retaining soil, regulating water flow, and maximizing agricultural output. Crops grow in meticulously rotated plots, nourished with mineral-rich sediments carried from distant rivers, while irrigation channels distribute water evenly across fields. Managed forests provide wood, fuel, and building materials without depleting resources, indicating an intimate understanding of ecological balance. Wild and domesticated species coexist in controlled zones, their patterns influenced by human activity, showing foresight in managing biodiversity. Defensive structures merge seamlessly with natural features. Walls may snake along cliffs or riverbanks, designed to be both imposing and functional. Watchtowers overlook plains and waterways, giving early warning of approaching threats, storms, or migrations. Each fortification integrates storage areas, water access, and hidden escape routes, ensuring resilience against both environmental challenges and potential conflict. Observation posts track not only human activity but patterns in wildlife and weather, blending surveillance, strategy, and environmental awareness. Energy harnessing appears in subtle ways. Water wheels spin in rivers, channeled to workshops and mills. Wind corridors are funneled along ridges to turn blades or direct airflow into cities. Heat-absorbing structures capture solar energy, while underground chambers utilize geothermal warmth for temperature regulation. Even tunnels and subterranean passages channel air, water, or energy, demonstrating an understanding of fluid dynamics, thermodynamics, and sustainability long before modern science formalized these principles. Quarries and mines reveal deliberate extraction and material mastery. Stone blocks are cut with exacting angles, metals smelted and shaped with knowledge of alloys and heat treatment. Roads lead directly from extraction sites to workshops or settlements, minimizing transport challenges. Subtle tool marks, residue from smelting, or layered excavation patterns provide a hidden history. Buried beneath sediment, ice, or volcanic deposits, waiting to be interpreted by modern eyes. Ports and engineered waterways suggest a command over hydrodynamics. Docks, levees, and canals control tides and currents, allowing the safe loading and unloading of ships. Sediment layers, artificially shifted rock formations, and linear alignments of stones along the coast hint at precise planning, as if the builders understood the fluid movements of oceans, currents, and seasonal changes. Trade, fishing, and transport operate in synchrony, guided by intelligence that manipulates natural forces without leaving jarring scars on the landscape. The city and its surrounding territory function as a living organism. Water flows, wind currents, and road networks interact seamlessly. Agriculture, energy production, trade routes, and defensive measures intertwine with forests, rivers, and mountains. Every contour, every carved stone, every channel of water represents deliberate design. Soil layers, terraces, quarries, and aligned stones form a complex network, telling a story not in words, but in the harmony of engineering and environment. The civilization's presence echoes through physical patterns, leaving behind enduring traces of ingenuity, foresight, and a society profoundly attuned to both nature and technology. Imagine stepping into a clearing just as the sun rises over a city built long before humans existed. The air hums with the quiet energy of activity, a rhythm dictated not only by survival but by curiosity, belief, and art. In this civilization, daily life unfolds in precise patterns, each action a part of a vast network of tasks, rituals, and observations. Streets paved with polished stone reflect the first light, glinting off surfaces worn smooth by countless footsteps. Smoke rises from hearths and workshops, carrying scents of roasted grains, herbs, and metals being shaped into tools, instruments, and ornaments. Communal spaces dominate the cityscape. Terraces, plazas, and open-air theaters are aligned to track celestial events. Carved stone markers catch the sunlight at specific times of day, casting shadows that intersect with engraved symbols. At dawn, a group gathers around a central platform, performing coordinated movements that mark lunar phases or seasonal transitions. Their chants resonate across valleys, layered with rhythms from drums carved from volcanic rock and flutes hollowed from bone. Every note carries instruction, memory, or a signal for coordinated labor, connecting individuals over distances without the need for writing. Art is integrated into every facet of life. Walls, floors, and pathways are adorned with geometric patterns, spirals, and symbols that encode information about weather patterns, river flows, and animal migration routes. Murals depict hunts, communal labor, celestial events, and ceremonial gatherings. Children trace fingers along the carvings as elders explain meaning, teaching navigation, astronomy, and societal roles through tactile observation. Even shadows cast by the rising sun highlight aspects of the patterns, creating a living calendar of natural events. Ritual objects are carefully crafted with dual purposes of functionality and symbolic communication. Polished discs, engraved with repeating marks, track lunar cycles, while small metal objects are stored in dedicated chambers as records of important events, floods, migrations, eclipses. The handling of these objects follows strict protocols. Specific members of society may touch them at certain times, creating an unbroken chain of knowledge and reinforcing the significance of observation, ceremony, and memory. Food and agriculture are central to both survival and culture. Crops are harvested at precise intervals and stored in terraced granaries, their placement reflecting both environmental conditions and ritual significance. Communal meals are orchestrated to reinforce social bonds, with the preparation and consumption of food intertwined with storytelling, music, and ceremonial practice. Certain plants may be prepared only during particular seasons, accompanied by chants or songs that convey agricultural wisdom and mythological associations. Music fills the air beyond ceremonies. Resonating chambers built into stone platforms amplify flutes, drums, and vocalizations, ensuring sound travels across urban spaces. Certain melodies mark the arrival of dawn, the planting season, or migration cycles, coordinating labor and ritual across the population. Performers memorize sequences that encode practical and spiritual knowledge, transmitting lessons in a format accessible to all ages. The spiritual life of the city is inseparable from observation of nature. Rivers, mountains, and caves are sacred spaces, each associated with specific rituals, deities, or celestial phenomena. Observatories align with the sun, moon, and stars, creating interactive spaces where learning, worship, and societal organization intersect. Members of the community study patterns in the sky, translating observations into practical guidance for agriculture, travel, and communal decision-making. Initiation rites immerse young members in both culture and environment. Journeys through forests, along rivers, or across mountains are designed to cultivate skills, awareness, and responsibility. Participants learn to read the landscape, track animals, interpret weather, and follow astronomical cues, acquiring both survival skills and cultural knowledge. Mentorship accompanies these journeys, blending hands-on instruction with ritualized storytelling. Storytelling is omnipresent, woven into daily activity, music, and ritual. Tales recount migrations, extraordinary weather, celestial events, and societal achievements. Heroes, tricksters, and natural forces populate narratives that teach survival strategies, ethical behavior, and observation skills. These stories are performed publicly, shared during feasts, or whispered in intimate gatherings, ensuring that each generation receives instruction, entertainment, and a connection to both the past and the environment. Even moments of leisure are deliberate and instructive. Games, contests, and creative expression sharpen skills, strengthen bonds, and reinforce knowledge. Sculpting, weaving, and crafting are practiced for both beauty and utility, often forming intricate patterns that reflect environmental or astronomical knowledge. Play serves as a method of exploration, observation, and experimentation, allowing participants to test strategies, refine tools, and engage creatively with both nature and society. Throughout the city, movement, sound, and material culture intertwine seamlessly. Children, elders, and artisans all contribute to a shared rhythm of daily life. Water flows along engineered channels that irrigate terraces, while producing sound patterns interpreted for timing and coordination. Wind passing through carved openings signals events or alerts, blending environmental awareness with cultural transmission. Tools, instruments, and ceremonial objects are continuously produced, refined, and reused, creating a tangible memory embedded in daily activity. The streets are alive with observation and experimentation. Stone surfaces reflect the sun at precise angles, shadows indicate seasons, and patterns in clouds and stars influence decision-making. People track animal migrations and river flows with detailed attention, incorporating these observations into rituals, art, and storytelling. Every element of the environment is engaged, analyzed, and integrated, creating a civilization whose entire existence is inseparable from the natural world. Imagine a civilization that didn't just exist in isolation, but actively explored, traded, and connected distant lands. Rivers, roads, and coastal routes act as arteries for movement, carrying not only goods but innovations, techniques, and culture. People move across mountains, plains, and oceans, guided by stars, landmarks, and detailed observation of their environment, recording patterns in stone or symbols that survive in subtle ways. Visualize caravans winding through valleys and forests along stone-paved roads. Oxen and pack animals, even simple watercraft, carry metals, tools, rare minerals, and agricultural produce. Settlements at crossroads hum with activity, markets crowded with traders, artisans, and scholars. Each journey requires adaptation to terrain and climate, careful planning and navigation, with travelers learning routes by memory, observation, and coded markers left behind by those who went before. Coastal settlements act as bustling ports, launching vessels built to endure waves, tides, and storms. Ships traversed rivers, lakes, and open seas, connecting islands, archipelagos, and distant continents. Trade flows across long distances, moving resources, cultural practices, and techniques. Stone markers, monuments, and navigational beacons encode distances, hazards, and resource locations, guiding travelers in ways subtle enough to persist across millennia. Along these routes, innovations spread rapidly. Agricultural methods, metalworking techniques, energy harnessing strategies, and architectural concepts move from one region to another, adapted to local conditions. Artisans might replicate decorative motifs, engineers reproduce structural designs, and communities exchange practical knowledge about environmental management. Observing these patterns, one can trace a network of intelligent movement, even if the original structures are long gone. Travelers carry stories, songs, and rituals alongside material goods. All narratives encode knowledge about geography, survival, and technology, reinforcing cultural identity while merging with local practices. Shared ceremonies, festivals, and artistic styles evolve as travelers integrate outside influences, blending astronomy, engineering, and artistry in ways that leave subtle traces across continents. Long-distance exploration demands detailed knowledge of climate, water sources, and seasonal patterns. Celestial navigation tracking stars, the sun's arc, or tidal cycles guides journeys. Travelers may carry symbolic maps, coded artifacts, or markers that function as both reference points and records. Every expedition teaches survival, resource management, and environmental mastery, expanding a collective intelligence that spans generations. Trade leaves marks in landscapes in ways both visible and invisible. Terraced hills, stone markers, and remnants of roads reveal ancient movement patterns. Mineral anomalies, clusters of artifacts, or unusual chemical traces in soils hint at commerce over vast distances. Even in the absence of standing structures, these signs indicate routes, interactions, and the movement of knowledge and resources. Cultural exchange flows alongside material trade. Art styles, religious symbols, and ceremonial practices travel with goods, creating hybrid forms that reflect both local and foreign influence. Communities may share engineering methods, astronomical observations, or agricultural knowledge, producing subtle but lasting evidence of intellectual exchange. Exploration extends beyond trade routes. Adventurers journey into forests, mountains, deserts, and islands, mapping terrain, noting water sources, identifying plants and animals, and marking resource-rich regions. Observations of climate, animal behavior, and geological formations feed practical decisions and storytelling alike. These expeditions generate local legends, survival strategies, and practical knowledge that ripple through societies, building complex cultural and environmental awareness. Settlements, monuments, and markers, though long eroded or buried, persist in subtle ways. Mineral deposits, isotopic anomalies, and aligned stone arrangements suggest deliberate shaping of the environment. Each path, each marker, each artifact serves as a node in a vast, interconnected system of exploration, trade, and cultural transmission. Knowledge is preserved in the land itself. Carved symbols, worn paths, water channels, and unusual distributions of materials, forming a hidden map of a civilization that moved, observed, and interacted with the world on a scale that stretches across continents and centuries. Imagine living in a world where mountains rumble, rivers overflow, and storms can reshape entire landscapes overnight. This ancient civilization, long vanished yet hinted at in the whispers of stone and soil, had to constantly adapt to forces far greater than themselves. Cities, roads, and fields were not simply constructed for comfort. They were designed to endure earthquakes, floods, volcanic eruptions, and the shifting moods of climate. Every structure and every pathway reflects lessons learned through generations of trial and observation. Picture a river swollen from seasonal meltwaters, surging with unstoppable force through a winding valley. Engineers of this civilization had carved terraces into steep slopes, channeling water safely and preventing catastrophic erosion. Levees stretch along the banks, reinforced with carefully cut stone and bound with metal, while elevated platforms hold homes above the reach of sudden floods. Bridges spanning the torrent are interlaced with resilient stonework, designed to flex rather than crumble, anticipating the river's raw energy. Communities study the skies, noting cloud colors, wind shifts, and humidity changes, predicting storms with intuition sharpened over lifetimes. Volcanic activity dominates parts of this world. Settlements are mapped around known lava flows. Yet when eruptions roar to life, observation towers and signal fires become lifelines. Ash blankets the valleys, drifting over crops and buildings alike, and inhabitants clear soil, rotate fields, and relocate livestock to higher ground. Every eruption is a puzzle to solve, a challenge to adapt to, and a force shaping construction techniques, agricultural practices, and logistics. Buildings are reinforced with interlocking stone. Soil channels divert water and debris, and crop cycles are recalibrated to survive the dust-filled skies. Earthquakes tear through cities, splitting walls and toppling towers. Yet the ingenuity of builders endures. Interlocking stones, shock-absorbing foundations, and subterranean channels redirect the energy of the trembling earth. Streets are subtly graded, walls bend rather than break, and essential structures are fortified with flexible supports. Underground granaries and vaults protect food and tools, while communal spaces are designed to withstand sudden collapses. Every tremor becomes a lesson in survival, integrated seamlessly into daily life. Storms and extreme weather shape the placement of structures and the rhythm of daily activities. Fierce winds sweep across open plains, dictating the orientation of homes, the planting of trees, and the positioning of walls and barriers. Communities watch cloud patterns, temperature changes, and seasonal cycles with acute awareness, timing work, travel, and rituals around moments of relative calm. Woven into these observations is an intuitive understanding of risk, safety, and the power of natural forces. In regions of ice and snow, the civilization's ingenuity continues to unfold. Terraced hillsides are shielded with layered walls, channels carry water while preventing freezing, and dwellings are aligned to maximize sunlight throughout the day. Herded animals are guided into warm enclosures, while underground storage ensures survival through long, harsh winters. Every action, from water management to housing design, aligns with natural cycles, demonstrating a deep-lived understanding of cold landscapes and the creatures that inhabit them. Droughts demand yet another set of adaptations. Reservoirs, cisterns, and channels channel water carefully across parched lands, sustaining crops and communities alike. Observation of rainfall patterns guides planting, harvesting, and even the timing of trade routes. Forests and grasslands are managed deliberately to prevent erosion, maintain soil fertility, and sustain food sources, showing an ecological intelligence that balances human needs with environmental pressures. Large-scale disasters shape cultural practices in parallel with practical strategies. Rituals emerge to interpret storms, floods, and volcanic eruptions, blending spirituality with survival. Ceremonies might occur during seasonal floods or storms, teaching younger generations to respect the power of nature while passing down practical knowledge. Monuments and markers, aligned with celestial or seasonal events, serve as both guides for daily life and symbols of collective memory and observation. Communication networks are woven throughout the landscape. Signal fires on hills, reflective surfaces catching sunlight, and acoustic devices carry warnings across valleys, rivers, and coasts. Observation posts relay information about approaching storms, wildfire, or migrating animals. The timing, distance, and terrain are all calculated intuitively, ensuring communities can respond quickly and effectively, turning knowledge into action and action into survival. Every wall, canal, terrace, and road becomes a testament to the civilization's ongoing negotiation with the world around it. Energy, materials, and ideas are channeled to create systems capable of resisting destruction while enabling growth. Homes and monuments are constructed with an awareness of shifting earth, water, and weather, each detail reflecting a balance between creativity, science, and instinct honed over generations. Their cities are living laboratories, constantly tested by fire, flood, and ice, evolving alongside the challenges of a restless planet. Imagine wandering through dense forests, deserts, or frozen plains, and suddenly coming across stones carved with intricate symbols, massive blocks arranged with geometric precision, or metal fragments that seem impossibly ancient. These artifacts whisper stories of a civilization so advanced that the faintest traces endure for millions of years, hidden beneath soil, ice, and layers of sediment. Some ruins rise from the ground as if frozen in time, their purpose obscured by eons. Giant foundations, circular enclosures, or long corridors of stone hint at organized urban planning. Streets may align with celestial events or water flows, showing knowledge of astronomy and engineering. Walls bear carvings that appear more than decorative, perhaps encoding events, achievements, or rituals, waiting for interpretation. Artifacts scattered across landscapes reveal technical skill and artistry. Tools forged from metals now eroded, ceramics with patterns of unknown significance, or fragments of polished stone that catch the sunlight all suggest deliberate craftsmanship. Broken pieces may indicate trade networks, resource management, or ceremonial use, implying a society with complex technology, culture, and social organization. Buried structures lie beneath layers of soil, volcanic ash, or ice. Mounds, terraces, and underground chambers suggest habitation, storage, or ceremonial functions. Intricate carvings, carefully shaped objects, and arrangements of stones aligned with astronomical phenomena hint at a sophisticated understanding of both environment and cosmos. Some artifacts defy easy explanation. Large stone spheres, carved blocks of unknown origin, or metallic objects in remote locations challenge modern understanding. Were they tools, monuments, or symbolic objects? Perhaps they served multiple functions: practical, ceremonial, and communicative, leaving traces that spark curiosity and research. Patterns appear when artifacts are mapped across regions. Repeated geometries, alignments with river paths, or consistent orientations of structures suggest shared culture, network settlements, or coordinated construction spanning vast distances. These arrangements hint at surveying, engineering, and possibly standardized systems of measurement. Certain ruins indicate adaptation to environmental extremes. Stone walls redirecting floods, elevated platforms guarding against rising waters, or tunnels carved beneath mountains demonstrate a civilization manipulating its surroundings. Faint evidence persists, marking ingenuity and foresight across landscapes. Artifacts may carry encoded information. Carvings, symbols, and spatial arrangements could reflect celestial cycles, resource management, or social hierarchies. Imagine a stone monolith that, when the sunlight strikes at dawn on a specific day, reveals hidden patterns, messages preserved through time, accessible only to those who notice and interpret the alignment. Even geological anomalies hint at human-like activity. Altered rock formations, unusual sediment layers, or distinct mineral concentrations could reflect construction, extraction, or symbolic placement. These subtle traces reveal interactions between civilization and environment far earlier than expected. As exploration continues, questions multiply. Who shaped these structures? How did they survive environmental changes? What knowledge of the Earth, sky, and cosmos did they possess? Each artifact and ruin opens windows into a world of complexity, ingenuity, and wonder, scattered across time and waiting to be examined. Thanks so much for watching. I'd love to hear from you. So drop a comment below and tell me where you're watching from and what time it is there right now. It's incredible to think that people all over the world are joining in on this journey through time. If you enjoyed the video, don't forget to hit that like button and subscribe so you won't miss any future adventures.